Okay, I'm going to go over the problems 1 through 5 on the 2017 Geometry Common Core exam. And if you want credit on this extra credit, opportunity that I'm giving to you, you have to write down all the notes that I tell you to write down, because that's one thing I'm going to be checking. All right? So, we're going to start with problem number 1. Now, it's asking, the question is, which equation represents the line that passes through the point -2, 2, and is parallel to y equals 1/2 x plus 8. Now, these are the things I'd like you to write down. We have the parallel lines have equal slopes. And I want you to write down the point slope formula. Okay? Now, I'll take a second, and you can pause the video and write this down. Okay, one thing you should notice. First of all, we talked about in class that what you want to do is identify the slope of the original line. So the slope of the original line would be right here. It's 1/2. All right, so the slope is equal to 1/2. Now, that should allow you to eliminate 2 of these answers. If you look at these, you can eliminate 2 and 4 because the slopes are different. So there's no way these 2 lines are going to be parallel because the slopes are different. Now, if you look at 1 and 2, they both have the same slope as our original, right? You have the slope here. So you have this slope is the same as this, is the same as this. So that means that all 3 of these lines are parallel. However, only one of them, only one, either this one or this one, actually goes through this point. Now, we actually plugged in the formula during class. If you were there, I would actually go to the calculator and just plug in both of these equations and see which one goes through -2, 2. So I'm going to go to calculator, and I'm going to plug in this one, and then we can eliminate one of them, because only one of them goes through -2, 2. So let's go ahead and put those in the calculator. All right, so my first one is 1/2 x. All right, and my next one is 1/2 x plus 3. Now, I'm just going to look at the first one, and if I go to the table, I notice that -2 and 2 is not a point. You see -2, -1, but not -2, 2. So that's not it. So I'm assuming it's the other one, but let's just make sure. So I'm going to go and check that one. I can graph it, look at the graph. Go to the table, and if you notice -2, 2 is a point. So that's our answer. And the thing is, they are both parallel, though. You can tell that, right? But only the top one actually goes through -2, 2. And, I'm sorry, not the top one. 1/2 x plus 3. So come here, and so my answer is number 3. Number 3, that's my answer. And we also did the plugging in class, but I'm not going to go over and do that again. Now, number 2. Again, you want to write these notes down. So these notes that I have, if you want extra credit, you're going to have to write all this stuff down. So all of this stuff I'm highlighting right now in green, you're going to need to write down. And I'm going to need to see it if you want credit for this. Okay? All right, so looking here, it says in the diagram below, triangle ADE. So triangle ADE would be right here, ADE. Okay, that is, okay, I'm going to have to take a break. I'll be right back. Okay, so let's get back here. ADE is the image of ABC after a reflection over the line AC, so that would be this line, followed by dilation of a scale factor of AE over EC, centered at point A. Now, some of this we really don't need to know. What I will say is that we know that this is not an enlargement, but a reduction in size, because the image ADE, which is all one in red, is smaller than the pre-image. So that means it was a reduction, okay? Also, whenever you do a dilation, similar figures are created, okay? So similar figures, all right? Now, what are properties of similar figures? You need to know this to do this problem. The corresponding angles are congruent. The corresponding sides are the same ratio. Now, if you look at our question, it says which statement must be true, and everything here is about angles. So really, that's the important part. So which one of these has to be true? Well, let's look here. Okay, so our first one says BAC. So BAC, so that's going to be this angle, is the measure is equal to AED, which is this angle. Well, now if we look here, BAC would be, let's go in order of the letters. Are those corresponding angles? So BAC, right? And AED. Nope. I'm sorry. Let me do that one more time. AED would be this. Okay, they don't go in the right order. So those are not corresponding angles, and they are not going to be necessarily congruent, or they're not going to have the same angle measure. All right, what about number 2? Measure of ABC. Let me go ahead and move these. Okay, now the measure of angle ABC, so that'd be this, and ADE. Now, are those corresponding? Well, if you look here, always look at the letters. They'll tell you a lot. So the angles ABC, and ADE. Right order, that means those are corresponding. That means that those are equal. These other ones, not necessarily true. So these are not our answers. All right. Okay, let's go to number 3. Let's go to number 3. And it's asking, given triangle ABC is congruent. Remember, this squiggly line on top of an equal sign means congruent. That means you can place two figures right on top of one another. All their corresponding sides are congruent. All their corresponding angles are congruent. You need to write all this stuff down if you want credit. Okay? Now, let's see, which statement is not always true? Okay, so 3 of these statements, 1, 2, 3, 4, 3 of them are true, 1 of them is not true. Okay, so let's look here. BC is congruent to DF. Is that true? Well, let's see. BC is here, and DF is here. No, those are not necessarily going to be congruent, right? So if we look at the other ones, the area of angle, I'm sorry, not the area, the measure of angle A, is that congruent to the measure of angle D? Yes, those are corresponding angles, all right? And these other two, we haven't talked much about them, but they are going to be true, and you should know, based on the lettering, that this is not always going to be true. It says not always true. That's not going to always be true. Also, be careful about the not. They always throw that in, which is not always true. They do that a lot, so be careful. All right, let's go to number 4. All right, now, it says in the diagram below, DE, so DE, DE, DF, and EF are mid-segments. What is a mid-segment? Well, we talked about this, but you need to write it down, write this stuff down. A mid-segment is the line segment connecting the midpoints of 2 sides of a triangle, okay? So DE is connecting the midpoints of BA. So D is a midpoint of this side, and E is a midpoint of this side, and then F is the midpoint of this side, okay? So that's what a midsegment is. Two special properties. It's parallel to the third side. So when I look at DE, it's connecting these two sides. So this one is connecting BA and BC. So it's actually parallel to this third side down here, right? Okay? And then this side is parallel to this side, okay? Now, let's look to see what they're actually asking us. All right. It says the perimeter of quadrilateral ADEF is equivalent to one of these following. Well, let's identify ADEF. ADEF, right here, ADEF, right, like that. What's the perimeter of that? Okay. So what we have to understand is that that's four sides, right? So we know that this side, right, DE, is equal to this side, because if DE is half, right, so DE is half of AC, right, that means that AF is going to be the same as DE. So AF is going to be the same as DE, right? And so we can do that. Then we also know that EF is the same as half of BA, AB. So I'm going to put 2 marks because all those have to be the same. All right. So now if you're looking at these different options, remember perimeter, which this is the outside. So adding up all the sides together, all right? Now, is it going to be AB? Is it going to be AB plus BC plus AC? No, I don't think so. I don't think so. Is it going to be 1/2 of AB? So 1/2 of AB would just be one of these, plus 1/2 of AC, which is one of these. Well, we're getting there, but that's only 2 of the sides, right? We need all 4. So we need this one, and we also need this one. So this isn't going to do it. What about 2AB? Well, 2AB would be taking this entire side and multiplying it by 2, and then plus this entire side multiplying by 2. No, that's not going to be what we want, all right? What we want, if we say AB plus AC, all right, I'm going to erase some of this, and let's go back and look at a couple things really quick. All right, remember, we said that this side and this side were the same, right? And this side. Okay, so if you take this side and this side, that's the same as this whole thing that I just did in green, right? So that's AB, right? Now, if I do DE, that's the same as each one of those. And so if I'm adding this one and this one, that's the same as the entire thing. So this was kind of complicated, I'll admit. But it's the type of problem you're going to see, so get ready for it. All right? Move on to the next one. Okay, it says in the diagram below, if triangle ABC is congruent to triangle CDF and line segment AEFC is drawn, then it could be proven that quadrilateral ABCD is one of these. Okay. Now, let's go back through this problem. First of all, you're going to have to write this stuff down. Okay, a quadrilateral is a 4-sided figure. Also, if 2 sides of a quadrilateral are congruent, and parallel to each other, then it is a parallelogram. Okay? So keep that in mind. So take a second and write that down. All right, let's look at the information we are given. It says triangle A, B, E. I'm going to write A, B, E is congruent to triangle C, D, F. All right? Okay, so we know, based on that, we know that AB is congruent to CD. So we can say this automatically, right? We also know that these two angles, right? Angle A, so that's this one, and angle C, right? And that means those are congruent. Now, we also now know, if we take this line, these lines, so we know that BA and CD are congruent, right? But are they parallel to each other? If they are, we can say that this is a parallelogram. All right? So let's see. Remember, when you have two lines cut by a third line, right here, you can do the Z. You can do the Z. And since these are congruent, that means that these lines are not only congruent to each other, they are also parallel. Now, one thing about a square and a rhombus, all right? Both a square and rhombus have 4 congruent sides. Okay, there is no way you can tell from this. You cannot tell that BC is congruent to CD. There's no way, based on the information, that we can know that. So there's no way we can say that it's a square or rhombus. All right? And we already determined, look at this piece of information, if two sides of a quadrilateral are congruent and parallel to each other, then it is a parallelogram. All right? The good thing about a lot of these problems on the new Common Core geometry, I mean, I know a lot of people don't like it, but one thing that is good is that the shapes are usually drawn to scale. So if you look here and you look at this angle, if it doesn't look like a 90-degree angle, which it would have to be a rectangle, then most likely it's not. It used to be they give you figures and they wouldn't be drawn to scale and just made it confusing. So right here, it's a parallelogram. All right, so that's questions 1 through 5. So hopefully you got that done and wrote down all the notes and handed in.